ओके, आगे अभी कंटिन्यू करो। ओके।
Okay. Uh, so earthquake prediction is about the prediction of earthquake, uh, of the time, place, and size of earthquake. So first of all, we have to be accurate in both place and time. Otherwise, it will be not useful. So how to predict the location? It is a bit easier than predicting time and size. So location is predicted on the basis of seismic gap theory. By this theory, we know that some regions in the Earth are completely aseismic, and some regions, like the active plate margins, they are seismically active. So we know the global seismicity pattern, the history. So from seismic gap theory, it is stated that the place which where seismicity is known to occur frequently but has not occurred in the long time, uh, so we can predict that it can happen there. Uh, so from elastic rebound theory, we know that the stress energy accumulates for a long time. After that, when it exceeds the local strength of the rock, the stress energy releases. So for the time the stress energy accumulates, there is no seismicity. So we can predict that the seismicity is going to happen soon. Now predicting time and size of the earthquake is bit difficult. So it depends on the local strength of the rock and the rate at which the strain accumulates. One of the sign is the abnormal animal behavior. Before earthquake, we can see some animals behaving abnormally. From that, we can predict. It has been seen that earthquake precedes the behavior. Also, one of the another thing is radon emission. There are some minerals in the earth which contain uranium. This radioactive uranium decays and emits the radon gas, which migrates through pores and can be detected at the surface. So it has been seen that the amount of radon is anomalous before just before the earthquake. There are some other symptoms like the changes in local geomagnetic field, etc., and the anomalous ratio of the travel time of S waves and P waves. And the most promising of that is the uh, amount of stress released in the most recent earthquake. So depending on the magnitude of the latest earthquake, the time elapsed, and the local rate of stress accumulation, we can say that the earthquake is going to happen soon, because a symptom of the stress accumulation is the force of activity. That is the small amount of uh, earthquake before the main earthquake. So from that we can predict the time of earthquake. So this is all about it. And another thing, we can measure the mm, change of the earth surface, uh, the horizontal and vertical motion of the earth surface surrounding a fault. Like we fix two position on both sides of the fault, and then by satellite laser ranging method, we detect the distance of the 2 points from the satellite. From that we can detect the distance between the 2 points by a certain accuracy. Now, if the fault plane changes, so the distance between those 2 points will change. Thus, we can detect the horizontal motion of the fault. From that, we can say how the stress energy changes and when the earthquake going to happen. So this is all about earthquake prediction. Now I am going to seismic refraction. First of all, the what is the basics of seismic refraction? The first arrival at any detector is always a direct ray or a refracted ray. Reflected ray is never the first arrival. So one of the positive sides of refraction, one of the easier sides, that if we only take the first arrival, um, we can calculate our uh, travel time curve easily. For reflection seismology, we have to take the second arrival or third arrival. But for refraction seismology, it is one of the positive point that we have to take only the first arrivals. Uh, so by plotting the first arrivals, we get the travel time curve, and from that we can obtain the velocity and depth. So by using the refraction seismology, we can image the subsurface structure of the Earth. So now the equation of refraction. For that, we have to assume the first of all, let us assume there are two horizontal interfaces. The travel time of the seismic wave, sorry, velocity of seismic wave through the upper layer is v1 and through the lower layer is v2. So if v2 greater than v1, then there will be critical refraction at some angle. That is called the critical angle. So if the incidence angle is equal to the critical angle, the ray will be critically refracted. That is, the refraction angle will be 90 degree, and a head wave will be generated. So it will pass through the upper part of the lower layer, and it will emerge at the surface at the critical angle. So the equation, the if we plot the equation, the travel time equal to t equal to x by v2 plus some intercept. So it will be a straight line. So from the slope of the travel time curve, we can obtain the velocity, that is the higher velocity, velocity of the lower layer. And if we plot the direct ray, we can obtain the velocity of the upper layer. And by knowing these two velocities and from the intercept, we can derive the depth. So there are 2 points. One is critical distance and one is crossover distance. At the critical distance, the two rays, reflected and refracted rays, they both arrive simultaneously. Before that, there was no refracted ray. And after the crossover distance, the refracted ray will be the first arrival. And then the second arrival will be the direct ray. So in general, we keep the short point and detector at an offset greater than the crossover distance, so that refracted ray is always the first arrival. And then we can move on to the three-layer case and multi-layer case. Just the mathematics will be difficult, and uh, we can obtain all the velocities of all the layers and the depth. And one interesting case is the dipping interface. In that case, there will be an extra parameter, the dip angle, which is an extra unknown. So we have to have extra number of equations. So what we do, we shoot a reverse profile. Um, Means that the short point become the detector point, and the detector point becomes the short point. So we have a more number of equations, and we can obtain the more number of unknowns like the dip angle. uh, Rest is mathematics only. So so another 2 point is blind layer. What is the blind layer? It results from that, suppose some layer, through some layer the velocity of seismic wave is less. Suppose layer 1 velocity is v1 and the layer 2 velocity is v2, which is less than v1. So there will be no critical refraction, so head wave will not be generated. And so suppose we cannot detect those layer, that is called the blind layer. So the depth, the amount of depth, we assume it will be overestimated. So this is one of the problem. And the rest of field survey method is same as reflection seismology, just only we have to keep the short point and detector at a certain offset. Otherwise it's same. And the application of this method, it is not applied in the hydrocarbon exploration, because it is not as useful to image the subsurface structure as reflection. But it can be used in construction purposes, like we can estimate the depth to rockhead, uh, because there will be the change of velocity, and we will get a refracted ray. From that we can derive the depth, and it is used in construction purposes. Otherwise it is used in a hydrogeological method, because in water layer there will be a rapid change of rapid no, there will be a big change of velocity, because of the water. So from that we can say that there is water underground. So in underground water exploration it can be used. And it is also used in crustal investigation, crustal seismology, large scale method. And also we can estimate the elastic constants. if we measure the velocity of both P wave and S wave, for P wave we use the vertical motion seismometer, and for S wave, that is the shear wave, we use the horizontal motion seismometer. Thus, using both type of detector, we can obtain the velocity of both types of waves, and from that we can obtain the elastic constants of the rocks. So these are the applications, and this is it. Thank you.
Okay, Agya. So I have one question. What
Yes.
is the ray parameter and what its significance?
Ray parameter is used for a multi-layer Earth, and it is a mathematical formula of the ray parameter is the sine of the incidence angle by the velocity of the immediate lower layer. And I have not studied it much because it's more of a mathematical formulation for the multi-layer seismic refraction case.
Okay.
Okay, Orgo, I have one question from earthquake prediction. So, can we predict earthquake or not? What should be the answer?
We cannot definitely predict earthquake. We can assume. Sometimes it has been seen those precursors have given good result. Sometimes it has not given correct result. So we cannot definitely say that we can predict earthquake. But from these precursors, from these events, we can assume that it may happen or it may not also. There is no definite method.
Okay, then what is in our hand actually that we can actually guess?
That is the location from the seismic gap theory that I just said. Those regions which is known to occur large earthquakes but have not occurred for a long time. We can definitely say that sometimes earthquake is going to happen there sooner or later.
Okay, and anything, if we measure the value of GPS values at that particular location or any unusual animal behaviors, this also may be the possible precautions. I did not
Yes, yes.
actually listen your uh, initial like talk, so I asked this question.
Yes, it is a possible source, but we cannot definitely say that from the abnormal animal behavior that it is earthquake is going to happen, or from the change in geomagnetic field. But these are precursors that have sometimes, by seeing that we have, it has been seen to precede the earthquake sometimes, but not always. So these are not the definite ways.
Okay.
Agya,
So
I have one more question. Why is Nepal is more prone to the earthquakes? Because we have recently also seen in the news there is number of earthquakes in the Nepal in last 2 weeks.
please repeat. Could not get.
Why is Nepal very much prone to the earthquakes?
I think it lies in some plate margin, that is some Indian plate or Eurasian plate. I don't know exactly, but it lies along the margin, because that is why I think it is more prone to earthquake.
Which type of plate boundaries is there?
Uh, I have forgot, but I think there are convergent plate boundary, divergent plate boundary, and constructive plate boundary. There are three types, I think.
Okay, okay, okay.
So Orgo, I have one question. So what What about around the depth of refraction seismology? There is any exact number?
Actually, it depends on the distance between the source and the detector. If the distance is large, we can get to much depth, and if the distance is small, we cannot get to much depth, I think.
Yes, much depth, but what is the maximum value if they ask what is your guess
That
value
is,
that
I don't know. I have not read it.
okay.
Okay, so any other question? Okay, I have some notes of this seismic reflection method. ओके आसुदीप आपने क्वेश्चन पूछा था ना रे पैरामीटर क्या होता है
Yes, Mohit.
आपको आइडिया है क्या क्या होता है कुछ
You please explain. I haven't read much more about it.
ओके 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 देखिएगा स्क्रीन विजिबल है क्या
Yes, Mohit.
देखिए यहाँ पे कुछ लिखा हुआ है रे पैरामीटर के बारे में एग्जैक्ट आइडिया मुझे भी नहीं है इसका जब अपन रिफ्लेक्शन विद कंटिन्यूअस चेंज ऑफ वेलोसिटी विद द डेप्थ की बात करते हैं ना वहां पे अपन रे पैरामीटर काम में लेते हैं तो देखना ये कुछ रे पैरामीटर को डिफाइन किया है यहाँ पे पी से डिनोट करते हैं अपन आर साइन आई अपॉन वी करके कुछ फॉर्मूला है बेसिकली क्या होता है जो अपना स्नेल लॉ होता है ना साइन आई अपॉन एन साइन थीटा कांस्टेंट होता है ना उसी टाइप से कुछ है कि साइन आई अपॉन वेलोसिटी इनका जो रेशियो होता है ना वो कांस्टेंट रहता है अगर क्या करें चेंज हो रहा है कंटिन्यूअस चेंज हो रहा है वेलोसिटी का विद द डेप्थ फॉर एग्जांपल के लिए ऐसे समझ सकते हैं कि कोई इस टाइप का कुछ वो है बेड रॉक है जहाँ पे वेलोसिटी जैसे रिफ्लेक्शन हो रहा है राइट समझ पा रहे हो क्या इसको इस रीजन के अंदर वेलोसिटी v1 है इस रीजन के अंदर वेलोसिटी v2 है इस रीजन के अंदर वेलोसिटी v3 है कंटिन्यूअस चेंज हो रहा है वेलोसिटी का तो यहाँ पे साइन जो इंसिडेंट एंगल है साइन i1 अपॉन में v1 और यहाँ पे जो इंसिडेंट एंगल है साइन i2 अपॉन v2 तो इस टाइप से इन सब का जो रेशियो होता है वो कांस्टेंट होता है उसको अपन रे पैरामीटर बोल देते हैं कुछ रिलेट कर पा रहे हो क्या इसको हेलो हेलो आसुदीप
हाँ बहुत हाँ
हाँ इसको कुछ अपन बैंड्रॉफ रिलेशन भी बोल देते हैं और यहाँ पे कुछ लिखा हुआ है डिटर्मिनेशन ऑफ रे पैरामीटर key to determining the variation of seismic velocity inside the रे पैरामीटर एक इम्पोर्टेंट पैरामीटर होता है साइस्मिक वेलोसिटी पता करने के लिए इनसाइड द तो ऐसा कुछ है कंप्लीट आइडिया नहीं है बट थोड़ा सा जितना आइडिया था ओके उसके अलावा ये कर्व आपने देखा होगा ना हेलो
हाँ सर मैं विमल हूँ।
हाँ
ऑडियो।
हाँ आप बोलिए
हाँ तो आपने जो रे पैरामीटर के बारे में जो बात किया,
हाँ
रे पैरामीटर इज ओनली यूज्ड इन spherical layers. Okay.
ओके
So when we are trying to measure the velocities uh, in a spherical layers inside the Earth, okay, then we have to take into consideration of the radius also. Okay, radius is the center. Okay, the distance between the center and the point from where we are measuring the seismic wave. Okay, so so I mean, so if we multiply the radius with sine I by v, okay, it will remain constant. Okay, so this factor, this whole factor is known as spherical ray parameter. Okay, so I just wanted to point out that it is valid for spherical layers. Okay, we use it in spherical layers. We don't use it in horizontal layers. Okay, are you getting the point?
ओके विमल, थैंक यू। बाकी सब बताइए, समझ में आया क्या? ये क्लियर हुआ जो विमल ने पॉइंट बताया?
हाँ हाँ,
विद्युत आगे?
यस 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 यस।
ओके ओके, सो नेक्स्ट कौन स्टार्ट करेगा? विद्युत, आपका टॉपिक क्या था?
मेरा आइसोस्टेट था।
आइसोस्टेसी, ओके। अमृत दास, आपका क्या टॉपिक था?
मेरा तो इंटरप्रिटेशन था।
इंटरप्रेट। और पवन, आपका?
मेरा इंस्ट्रूमेंट था, इंस्ट्रूमेशन।
बेसिक बेसिक किसका था?
अर्पिता, आपका क्या था?
मेरा करेक्शंस था।
करेक्शंस, ओके। गौरी?
फील्ड ऑपरेशन।
फील्ड ऑफ। तो बेसिक्स अपन ने किसको बोला था? जस्ट फॉरगेट। ओके अर्पिता, आप स्टार्ट कर दीजिए करेक्शन से।
आई थिंक सोनू सोनू नहीं है।
ओके ओके, वो जब ज्वाइन करेंगे तो अपन डिस्कस कर लेंगे। अर्पिता, आप करेक्शन स्टार्ट कर दीजिए, देन फिर फील्ड
ओके
ऑपरेशन और जो भी हो।
ओके। So basically, the gravity everywhere on the Earth surface is not same. इसके बहुत सारे reasons हैं. First is the shape of the Earth. Next is the distribution of the mass in the various layers, and next is topography. So Earth is not a perfect homogeneous sphere, and hence gravity is not constant at the Earth's surface. तो gravity का जो magnitude है, it depends on 4 to 5 factors. Number one is latitude, then elevation, then topography, then earth tides, and then the density variations. तो लैटिट्यूड पर वो कैसे डिपेंड करता है? इट इज कि जो अर्थ का जो शेप है दैट इज ऑब्लेट स्फेरॉइड. तो हम ये देखते हैं कि जो ग्रेविटी जो पोल्स पर है दैट इज 9.83 मीटर पर सेकंड स्क्वायर, बट जो ग्रेविटी इक्वेटर पर है दैट इज 9.78 मीटर पर सेकंड स्क्वायर. और जो डिफरेंस है दोनों का दैट इज 5186 मिली गैलीलियो. हमने ये देखा कि सॉरी, हाँ हाँ, जो ग्रेविटी जो पोल्स पर है दैट इज मच बिगर देन द ग्रेविटी एट द इक्वेटर. बट एक्चुअली वो 5186 नहीं होनी चाहिए. पहले हम ये डिस्कस करते हैं कि ग्रेविटी जो पोल्स पर है वो ज्यादा क्यों है. तो इसके दो रीजन है हमारे पास. जो डिस्टेंस एट द सेंटर, द डिस्टेंस फ्रॉम द सेंटर ऑफ मास of the earth is shorter at the poles than at the equator. That means small g is equals to gm by r square. G is inversely proportional to 1 by r square. So the distance from the center of the earth to the poles is smaller. That's why the gravity at poles is bigger by a factor of 6600 milligalileo. Or there is one another factor, that is centrifugal force, that tries to diminish the gravity at the equator, that gives rise to an excess gravity of 3375 milligalileo at the poles. तो इस अकॉर्डिंग तो हमारे पास टोटल जो ग्रेविटी है एट द पोल्स इट शुड बी 9975 मिलीगैलीलियो. बट what we observe, it is only the difference of 5186 milligalileo. So it can be the question ki why the observed gravity difference at the poles and equator is only 5186. It should be 9975. तो इसका ये रीजन है ड्यू टू द इक्वेटोरियल बल्ज that places an excess of mass in the equator that cause the increase in the equatorial gravitational force, and hence the net differences in the gravity, it is approximately 5186 milligalileo. Next is elevation. Elevation is, if we consider the earth as a homogeneous sphere, so we will see that we all know one formula. G is g naught 1 minus 2h by r at the height h above the datum, and g is g naught 1 minus h by r at the depth h. बट ये फॉर्मूला तब एप्लीकेबल है जब हमारा जो है वो परफेक्ट होमोजेनियस स्फीयर है. बट ऐसा पॉसिबल तो है नहीं। तो दैट्स वाई अब हम डिस्कस करेंगे कि ये जो करेक्शंस हैं, कि अगर अर्थ रोटेट कर रहा है और उसकी जो शेप है दैट इज ऑब्लेट स्फेरॉइड, वो परफेक्ट होमोजीनियस नहीं है, तो अब हमें ग्रेविटी करेक्शन बेसिकली चाहिए क्यों? लेट मी शेयर माय स्क्रीन। तो सबसे पहला क्वेश्चन है कि व्हाई ग्रेविटी करेक्शन? इज माय स्क्रीन विजिबल?
यस सर पिता विजिबल, कंटिन्यू।
तो सपोज दिस इज अ डेटम जहां पर हमें वैल्यू चाहिए, तो डेटम के नीचे हम ये कंसीडर करके चलते हैं कि जो अर्थ की जो एवरेज डेंसिटी है दैट इज अप्रोक्सीमेटली 2.6 cc। तो हम ये और अगर हमें थोड़ा सा हाइट एच पर अगर हमें एक वैल्यू चाहिए, तो हाइट एच पर उसकी वैल्यू कुछ कम होगी। हाँ, कुछ कम होगी। तो अगर हम बट हमें जो वैल्यू चाहिए दैट शुड बी एट दी डेटम, तो इसलिए उस उस हाइट एच में हमें कोई ना कोई करेक्शन ऐड करनी पड़ेगी सो दैट कि हमें डेटम पर वैल्यू मिल पाए। ठीक है, तो इस वजह से हम लोगों को करेक्शंस चाहिए होती हैं। जस्ट अ मिनट। हाँ, तो अब हम बात करते हैं लैटिट्यूड करेक्शन की। द लैटिट्यूड करेक्शन इज रिक्वायर्ड इफ द स्टेशन वेरीज इन द नॉर्थ टू साउथ पोजीशन, that is with the variation in the latitude but not required with the variation in the longitude position। तो इस सेकंड, हाँ, अगर हम बात करें सिर्फ नदर्न हेमिस्फीयर की, तो अगर हम एक रेफरेंस पोजीशन लेते हैं, तो अगर हम उस रेफरेंस पोजीशन से अपवर्ड साइड जाएंगे तो हमारा लैटिट्यूड करेक्शन विल बी नेगेटिव, और अगर हम लैटिट्यूड करेक्ट रेफरेंस पोजीशन से टुवर्ड्स द इक्वेटर साइड जाएंगे तो लैटिट्यूड करेक्शन विल बी पॉजिटिव। तो इट इज एप्लीकेबल इन द नॉर्दर्न हेमिस्फीयर एंड आई हैव डिस्क्राइब्ड इट आल्सो फॉर द सदर्न हेमिस्फीयर। अगर हम टुवर्ड्स इक्वेटर जाएंगे देन इट विल बी पॉजिटिव, और अगर टुवर्ड्स सदर्न टुवर्ड्स साउथ जाएंगे तो इट विल बी नेगेटिव। तो यहाँ से क्वेश्चन अराइज होता है, while latitude correction is positive when we move towards the south and the latitude correction is negative when we move towards the north। तो इसका एक एग्जांपल हो सकता है कि सपोज हमारे पास एक बहुत हैवी रिवर फ्लो कर रही है, और अब हम कोई हमारे पास कोई सुपर पावर तो है नहीं कि हम बीच में खड़े होकर ग्रेविटी को मेजर कर पाए। तो या तो हम उसके टुवर्ड्स द नॉर्थ जाकर उस ग्रेविटी की वैल्यू को मेजर करेंगे, आइदर अबव और आइदर बिलो। नॉर्थ या साउथ में हम किसी एक जगह जाकर ग्रेविटी की वैल्यू को मेजर करने की कोशिश करेंगे। तो अगर हम नॉर्थ की तरफ जाकर मेजर करेंगे तो वहां पर ग्रेविटी की वैल्यू ज्यादा मिलेगी। तो ऑब्वियस सी बात है कि अगर हमें रिवर के किसी मिड पॉइंट पर वैल्यू चाहिए तो हमें उसे ग्रेविटी की ओरिजिनल वैल्यू में से माइनस करना पड़ेगा। बट अगर हम साउथ की तरफ जाएंगे तो हमें ग्रेविटी की वैल्यू कम मिलेगी, देन वी विल एड इट। So that's why latitude correction is positive when we move towards the south, but it is negative when we move towards the north. Is it clear? बहुत फास्ट तो नहीं हो रहा ना? हेलो?
यू
ये
कंटिन्यू
सर,
अर्पिता।
या सही है, कंटिन्यू कीजिए।
तो नेक्स्ट करेक्शन इज अ फ्री एयर करेक्शन। फ्री एयर करेक्शन के लिए अगर हमारे पास एक डेटम है और अगर हमें स्टेशन पे मेजर डेटम से ऊपर मेजरमेंट करना है हाइट एच पर, और इन बिटवीन द स्टेशन एंड डेटम देयर इज अ एयर, तो फ्री एयर करेक्शन विल बी पॉजिटिव। और अगर हमें बिलो द डेटम मेजर करना है, बिलो द डेटम मेजर करना है देन इट विल बी नेगेटिव। तो हम देख सकते हैं कि हाइट की वजह से जब हम हाइट h पर है तो ग्रेविटी की वैल्यू डिक्रीज कर जाएगी। तो अगर हमें डेटम पर उसकी वैल्यू चाहिए तो हमें g ऑब्जर्व्ड एट डेटम इज इक्वल टू g ऑब्जर्व्ड एट हाइट h प्लस FAC होना चाहिए। बट अगर हम डेप्थ h पर है तो ग्रेविटी की वैल्यू बढ़ जाएगी, इसलिए फ्री एयर करेक्शन को हमें उसमें से माइनस करना पड़ेगा। नेक्स्ट वन इज अ बॉगर स्लैब करेक्शन। इन दिस हमारे पास दो केस हैं कि या तो हाइट h तक हमारे पास एयर हो, या फिर द सेकेंड केस इज वहां पर कुछ माउंटेन्स यानी कि कोई मास प्रेजेंट हो। जब भी मास प्रेजेंट होगा उस केस में हम बॉगर स्लैब करेक्शन को यूज करेंगे। तो और जब भी बॉगर स्लैब करेक्शन अप्लाई होगा तो फ्री एयर करेक्शन हमेशा अप्लाई होगा, क्योंकि हाइट h की वजह से तो फ्री एयर करेक्शन आएगा, बट अगर कोई मास प्रेजेंट है तो उसकी वजह से बॉगर स्लैब करेक्शन आएगा। तो अगर हम बात करें कि एट हाइट h अबव द डेटम, तो मास m की, बिकॉज वी ऑल नो स्मॉल g इज इक्वल टू जी एम बाई आर स्क्वायर, तो मास m की वजह से तो जो ग्रेविटी है वो हायर होगी अबव द स्टेशन, तो इसकी वजह से ग्रेविटी की वैल्यू बढ़ जाएगी और बॉगर करेक्शन जो है वो नेगेटिव हो जाएगा। बट अगर हम बात करें हाइट h की, तो हाइट की वजह से ग्रेविटी की वैल्यू कम हो जाएगी, देन FAC विल बी पॉजिटिव। अगर हम ऑपोजिट बात करें बिलो द डेटम, तो अगर बिलो द डेटम अगर हम बिलो द डेटम बात करें तो डेफिशिएंसी ऑफ मास की वजह से ग्रेविटी की वैल्यू कम हो जाएगी, तो बॉगर करेक्शन जो है वो पॉजिटिव हो जाएगा, और डेप्थ h की वजह से ग्रेविटी वैल्यू बढ़ जाएगी जिसकी वजह से FAC विल बी नेगेटिव। तो हमेशा FAC और बॉगर करेक्शन दे विल बी ऑपोजिट इन द साइन। Next come is the elevation and the terrain correction. Elevation correction is basically a free air correction plus the bogger correction. जो अगर हम डेटम से ऊपर मेजर करेंगे तो इट विल बी पॉजिटिव, और अगर हम डेटम से नीचे मेजर करेंगे देन इट विल बी नेगेटिव। टेरेन करेक्शन इज वो हमेशा पॉजिटिव होता है। इट इज अप्लाइड when we have an undulated topography, यानी कि एक तरफ माउंटेन हो और एक तरफ बेसिन हो, हम उस केस में टेरेन करेक्शन यूज करते हैं। और हाँ, नेक्स्ट इज ड्रिफ्ट करेक्शन। ड्रिफ्ट करेक्शन इज बेसिकली ड्यू टू द इंस्ट्रूमेंटल एरर। जो अगर कोई भी हम इंस्ट्रूमेंट यूज करेंगे तो हम ड्रिफ्ट करेक्शन हमेशा ही यूज करेंगे, एंड सिमिलर विद द टाइड्स करेक्शन, दैट इज ड्यू टू द ग्रेविटेशन अट्रैक्शन ऑफ द सन एंड मून। तो अगर हम कभी भी कोई भी मेजरमेंट करेंगे तो ड्रिफ्ट और टाइडल करेक्शन को हम हमेशा कंसीडर करेंगे, क्योंकि ये इफेक्ट ऑलरेडी प्रेजेंट रहेंगे। So I think that's for my part.
Yes, I have one question.
Yes.
So yeah. So why the terrain correction is always to be added?
Mhm. बेसिकली अगर एक तरफ माउंटेन होगा और एक तरफ बेसिन होगा, तो क्या कहते हैं, माउंटेन तो एक्स्ट्रा ग्रेविटी को लगाने की कोशिश करेगा, बट बेसिन उतनी ग्रेविटी को एक्सर्ट नहीं कर पाएगा, तो शायद इस वजह से टेरेन करेक्शन इज ऑलवेज पॉजिटिव।
Okay, okay.
अगर किसी के पास और बेटर आंसर है तो प्लीज लेट मी नो।
Okay, I think, am I audible?
Yes, yes.
या
हाँ, तो माउंटेन के केस में क्या होता है, बेसिकली देयर आर टू केसेस, ओके, इन केस ऑफ टेरेन करेक्शन, और ओके, So one case is when there is any mountain or hill lying near the point where we are taking the gravity measurements, okay? And the other case is when there is a valley, okay?
Can
Valley
you
is the
repeat?
abs,
Please?
huh? Okay. So
Can you
what I
repeat,
was
please?
saying, yeah, what I was saying is that there are two cases, okay, in terrain correction. One is that if there is a mountain lying near the point of survey, okay, and there is a valley, okay, there might be a valley or a mountain near the point where we are taking the measurements, okay. Now, in case of mountain, what will happen is that the gravity will act upwards. Are you getting my point? Gravity will
Yes.
act upwards because mountain is lying above the surface, okay. So so there is a reduction in gravity, okay. So since there is a reduction in the gravity, so in the observed gravity we add the gravity value, okay. Are you getting my point? Similarly, in case of in case of valley, which is nothing but the absence of mass, okay. Valley is what? Valley is the absence of some, there is some depth lying near the gravity point where we are measuring the gravity, okay. So in case of valley, that is absence of mass. So once again we have a reduction in the gravity, okay. So once again we have to add this value in the observed gravity data. So in both cases, mountain as well as valley, we have to add this correction. I mean, we have to add this gravity anomaly due to mountain or valley. Okay, so have you got? I mean, have you understood it?
Yeah. Yes.
Yes,
Thank you,
it is
Vinod.
given. Yeah, it is given in Lottie. You can read it. Okay.
Arpita, I have one question.
Yes.
What is the reference ellipsoid?
What is?
What is the reference
Repeat.
ellipsoid? Reference ellipsoid.
Um, it is basically that best fits the geoid mathematical representation, we can say.
What is the okay? And why we are using it? Okay, what is the real shape of the Earth?
Oblate spheroid.
Okay, so have you heard about the geoid?
Yeah.
So which one is the real shape of the Earth? Is it reference ellipsoid or geoid?
It is geoid.
Okay, then why we are not using?
Basically, ellipsoid is the ellipsoid we are using for the mathematical representation कि हमारे पास कोई एक perfect figure है और हम उसके according calculations कर सकते हैं और geoid is basically for the reference I don't know. You please
Okay,
tell.
you are correct. The reference ellipsoid is the more geometrical regular shape, so it can be best described by the mathematical equations. But geoid, sorry, reference ellipsoid. But geoid is the real shape of the Earth. That is, it is a physical equipotential surface of the gravity. But in the mathematical formula to compute it, it is very difficult to compute in the mathematical formula. So to deal theoretically, we are using the reference. That's why we are calling it the reference ellipsoid. We are taking it as a reference. You got it?
Yeah, yeah. Thank you.
And Ansudeep, we also add something in geode. Geode have a inhomogeneous surface, and ellipsoid have a homogeneous surface.
हाँ हाँ हाँ, वही है कि इलेप्सॉइड की रेगुलर शेप है जो तभी वो होमोजेनियस सरफेस में आता है
Yes.
एंड जो तो है इरेगुलर शेप है वो.
Is this datum surface we are referring is equal to the geoid?
Can you repeat, Gauri?
The datum surface, no, you with reference to which we are correcting the gravity value, is that equal to geoid?
Yeah, we can say geoid, I think.
Okay, okay.
Is it correct?
I think
don't
it's
know.
the ellipsoid, the international reference ellipsoid. That is, we know the values of gravity on that. So that is the datum point, I think.
I think datum point we consider on the reference ellipsoid, not on the geoid.
Okay.
जियोइड तो हम कहीं यूज ही नहीं करते एक्चुअली फॉर्मूलेज में, वो तो आइडियल चीज है और आइडियल तो एग्जिस्ट करता ही नहीं है कहीं. तो तो थ्योरेटिकली हमें डील करना है, सो वी विल यूज द इलेप्सॉइड एवरीवेयर. कहीं कहीं आपने इलेप्सॉइड को रिप्लेस कर दिया ऑब्लेट स्फेरॉइड से, तो बोथ आर द सेम.
हेलो अर्पिता, ये
Yes,
करेक्ट
Mohit.
हो गए क्या कंप्लीट?
Yes.
ओके, सो नेक्स्ट वन कौन स्टार्ट करेगा? विद्युत.
Comments, please.
आई
Okay.
Mohit, I think I should go for the anomaly part. Next is
ओके
anomaly.
ओके,
With it,
कंटिन्यू.
if you have not any
Please
problems, then
comment भी बता दो.
ओके, एनीवन? आप बाकी सब लोग है ना, सजेशंस बता सकते हो अर्पिता एंड आरके के लिए, जो भी गुड्स एंड बैड्स हैं. पवन.
I think it's good for presentation as well as and content wise also good.
आसुदीप, विद्युत, आप भी बता दीजिए. गौरी,
Yes,
विमल.
yes, yes. Yeah, I think both are good. Both are explained very well, and also communication skill also is good.
Apita, one suggestion for you. Actually, when you are giving the answer, try to more confident.
Okay. Yeah.
If you are using such words, if it may or can, or it may lead to the lower confidence. So
Okay.
okay.
I'll definitely do that. Thank
Otherwise,
you.
communication, everything are fine.
Okay, Gori, any suggestion from your side?
Yeah, her presentation was nice.
Vimal, Amritas.
Yeah, I think it was nice. I will just say that also focus more on why. Okay, for example, why anything is positive, why anything is negative, why we are adding anything. Okay, in gravity corrections. So we also need to focus more on why. Okay, because generally they will ask questions. I mean, when they will ask one question, then subsequently they also ask why. Okay, they don't just stop there. Okay, so we have to focus on why also. Okay.
Okay.
आरके के लिए भी बता दो. एनी सजेशन इफ यू फाइंड? आसुदीप, गौरी, विद्युत, विमल.
Yeah, RG ka some everything was good.
Yes, yes,
नहीं
और
आंसर
होगा
तो अच्छा
चलो।
है.
अच्छा ही बोला।
He has good amount of knowledge.
यस यस।
ओके, सो आंसुदीप आप कंटिन्यू करो अभी।
I think one more correction has not been told. That is the yacht was correction for the moving vehicle. That must be added or subtracted according to the eastward or westward velocity.
या अर्पिता, would you like to tell something about this Ito's correction?
No, actually, I haven't got much into it.
Okay, आगे आप बता दीजिए if you know that.
If we measure gravity on a moving vehicle that is moving eastward, mathematically it can be shown that the measured gravity value decreases. So the Eutovos correction must be added, and if we measure gravity on a westward moving vehicle, the measured gravity increases. So the it must be subtracted.
Okay, okay. Asudeep, you can continue now. Hello, Asudeep.
Okay, Mohit. So, thank you, Mohit. I will go for the anomaly part. So, what is the gravity anomaly? So, as Apita said, we are calculating the corrected values of the in the sorry, not calculating. We are correcting the measure value of the gravity. So, we will subtract this value from the theoretical values. So, theoretical values are the calculated at the reference ellipsoid, and we have also measured the values and also corrected that, so that we हमने क्या किया है कि measured values को उस reference ellipsoid पे put कर दिया है लाके. So now we can compare the both the values. So gravity anomaly is the difference between the measured corrected value minus the theoretical value of the gravity. Why it is happening? It is all due to the density contrast between the rock and the host rock or the surrounding rock. So there are two type of the gravity anomaly. First one is the free gravity, free air anomaly, and it includes the observed gravity जो simply हम instrument से measure करेंगे. Then it all include the free air correction. Then it also include the strain correction and tide correction, and then minus the theoretical value. And then second one anomaly is the Boyger and gravity anomaly, which include the all the corrections. So free air anomaly does not include the Boyger plate correction, but Boyger anomaly includes all the corrections. And okay, so interpretation के part में तो बाद में जाएंगे. So just okay. So, how we can model these gravity anomaly? Is there any theoretical model so that we can predict, calculately predict the model for the gravity? Yes, they are traditional models or the geometric models, and they are the modern models. In the modern models, we will do the iterative modeling by the computation computers, but in the traditional models or the geometric models, we simply assume the shape of the buried body object, and from that shape of the body, we try to calculate the gravity anomaly formula. We can from that we can predict something. So, where we have the three type of the main models: the 1D model, 2D model, 2.5D model, and the 3D models. So first we will see the 3 model, that is assume a 3D spherical body sphere assume कर लेते हैं, which उसका mass m है, density contrast जो delta rho ले लेते हैं, and it is buried at the uh, depth at z. Z is the distance between the surface and the center of the sphere. So we will take the vertical part of the vertical part of the gravity, so it will have the maximum contribution because vertical part का ही maximum contribution है, that's why we are taking the only the vertical part. So after the some calculations we can calculate. So we get the formula like the gravity anomaly due to the sphere is is equal to the some z naught 1 by 1 x plus z, something like formula. So first term in this is the anomaly amplitude part, like the mm, in the decay system or in any decay system we get the amplitude part. It is here the amplitude part, maximum amplitude part. And second term is the 1 by 1 plus x by z square, or whole to the power 3 by 2. It is all to the decay part. So as x increases with what is the x? So if I draw a vertical from the center of a sphere to the surface, then it will suppose it intersect at a point O. Assume it O. Then the distance from that point, observing point, between the that O point and the station or the observing point is the x. अगर हम सेंटर के जस्ट अब ऊपर खड़े हैं तो वो जीरो डिस्टेंस होगी, और जैसे जैसे हम दूर चले जाएंगे वो डिस्टेंस ये एक्स डिस्टेंस है. सो जैसे 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 एक्स बढ़ाएंगे वो डिस्टेंस बढ़ती जाएगी. और एम्पलीट्यूड एनोमली क्या है, कोई 1 बाई में है, 1 बाई एक्स स्क्वायर समथिंग में है, तो वो डिक्रीज होते चली जाएगी. सो इस एनोमली करके व्हाट आर द कैरेक्टरिस्टिक्स? So it this curve is symmetric about x is equal to 0. So and it has the maximum value at the x at the x is equal to 0 means कि just above the center of this sphere वहाँ 0 होगी. And it has the it will decrease it, जो वैल्यू वो डिक्रीज जीरो की तरफ अप्रोच करेगी जैसे जैसे हम उस सेंटर वाले पॉइंट से दूर तक चले जाएंगे, चाहे वो कोई सी डिस्टेंस में हो, पॉजिटिव और नेगेटिव में. और जितनी ज्यादा डिस्टेंस पे actually formula without formula, actually I don't know whether you are getting it or not. or may, are you getting? Hello.
हाँ ठीक है,
Yes,
चलो.
yes.
Yes, Asujit, continue.
Okay, 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 thank you. So suppose हमने डिस्टेंस अब उसकी इंक्रीज कर दी है, जो भी हमारा स्फेयर है. देन उसका क्या होगा, स्फेयर डिस्टेंस इंक्रीज करने से एम्पलीट्यूड डिक्रीज होगा, पर अब वो मोर स्लोली डिक्रीज होगा एज कंपेयर टू प्रीवियस एक्स की वैल्यू के अकॉर्डिंग. सो हियर वी कैन सो एक एक्स जो है एक्स डिस्टेंस पे ऐसी एक एक्स वैल्यू है वेयर द एम्पलीट्यूड एनोमली डिक्रीज टू हाफ इट्स हाफ वैल्यू. सो उस डिस्टेंस को एक्स को हम बोलते हैं द हाफ हाइट विड्थ. एंड फ्रॉम फॉर्मूला वी कैन कैलकुलेट इट. सो जनरली हम एनोमली कर्व से दो चीज मेन क्या है, दो चीज फाइंड आउट कर सकते हैं. फर्स्ट वन इज द डेप्थ, एंड सेकंड वन द मास ऑफ द स्फीयर. सो एक्सपेरिमेंटली क्या है, हमें एक्सपेरिमेंटली क्या मिलेगा, हमें ग्रेविटी एनोमली कर्व मिलेगा. विल गेट द ग्रेविटी एनोमली कर्व. सो फ्रॉम दैट ग्रेविटी एनोमली कर्व वी कैन कैलकुलेट द हाफ width ऑफ द कर्व. सो और हाफ width के टर्म में हमें जेड भी पता है और एम भी पता है. सो हम क्या कर रहे हैं, हम इनडायरेक्टली कि उस चीज से जो हमारी बड़ी स्फेयर है उसकी हम डायथ भी निकाल रहे हैं, और उसका कितने अमाउंट में है. सो डेफिनेटली ये बेनिफिशियल होगा अगर हम सर्वे करना चाह रहे हैं तो. ये हमें पता चल गया. बट एक प्रॉब्लम है इसमें कि ये क्वांटिटी जितनी है ना, कि डिफरेंट डिफरेंट बॉडीज भी सेम ग्रेविटी एनोमली को रिप्रेजेंट कर सकती हैं. और यही इसकी जो प्रॉब्लम है पूरे मेथड की, यही प्रॉब्लम होती है इसमें, बिकॉज दे आर दी नॉन यूनिकनेस प्रॉब्लम्स. कि एक यूनिक सोल्यूशन नहीं मिल रहा है, तो डिफरेंट डिफरेंट कोई भी डिफरेंट ऑब्जेक्ट होगा वो सेम पिक्चर को ड्रॉ कर सकता है. सो इट्स ऑल अबाउट इट. एंड सो अभी 3D सिमेट्रिक स्फीयर का हुआ है, देन वी विल सी द 2D बॉडी. सो 2D में क्या है कि एक इनफाइनाइट लेंथ की होगी बॉडी जो बड़ी होगी, और जो 2.5D स्ट्रक्चर होगी. सो उसमें क्या है, इनफाइनाइट लेंथ की बॉडी तो होगी, बट उसके हम एंड इफेक्ट जो होंगे, क्रॉस सेक्शन होंगे, उन्हें भी काउंट करेंगे. So if we are adding, including the end effects of a infinite horizontal length cylinder or a wire, then it is the uh, 2.5D body. Or if we are not including the end effects, then this problem is refers to the 2D problem. So here we can see that the horizontal 1D element की हम calculation करेंगे, then it is a very simple calculation. We can assume an small element of of the length some dy and mass dm, और वहां से हम कैलकुलेट करेंगे तो नियरली रिलेशन इज सेम, और वहां से एक फॉर्मूला आता है हमारे पास logarithmic पोटेंशियल का. So this formula is varying as the something ln by u. So u is a distance में, that's why ln is log की फैक्टर की वजह से we are calling it the logarithmic potential. तो नियरली सेम ही है लगभग लगभग इसमें भी, और इसे हम एक्सटेंड कर देंगे फर्दर. तो अगर हम बहुत सारे लाइन एलिमेंट्स को पास पास ला के ऐड करेंगे, एंड वी विल गेट एन इनफाइनाइट हॉरिजॉन्टल सीट, और उससे ही हमारा सीट सीट का फॉर्मूला आ जाएगा, जिसे हम बर्गर प्लेट करेक्शन, बर्गर प्लेट जैसा जो फॉर्मूला होता है सेम उसी फॉर्मूले से हमें मिलेगा. सो आई थिंक आई हैव आल्सो डन अबाउट दिस. ओके. So Mohit, I have done from my side.
Mohit is not there, I think.
मोहित हाँ
Anshul,
नहीं
I
है.
have one question.
Yes, yes.
Generally, we use a Boger anomaly. We do not use inferior anomalies in interpretation.
I didn't. Sorry, I didn't get your question. Will you please repeat?
Yeah, I repeat that. In generally data interpretation, we use Boger anomaly and not use a Freer anomaly.
Okay, okay. We are not using the Fourier anomaly. Why?
Yeah. Yeah.
Um, sorry, I will have to look upon it.
ओके. एंड सेकंड क्वेश्चन ये है कि यहाँ ग्रेविटी मेथड में क्या होता है कि एम्बिग्यूटी होता है एनोमलीज में. अपन एक सोर्स है, डिफरेंट डिफरेंट सोर्स, उनका एनोमली अपन को सेम मिलता है. व्हाट पॉइंट.
Y- Yes, yes, yes.
तो
That is
कैसे
the
उसका
non uniqueness
इंटरप्रेशन,
problem.
तो कैसे उसका इंटरप्रेशन करेंगे फिर.
We can interpret the possibilities, but it will not lead to the unique solution. And it is the problem of the uh, it is the interpretation problem in these all methods. And because different density distribution can lead to the same gravity anomaly, as I said earlier. So that's why these methods all are the have the probabilistic interpretation, not accurate.
यस यस. विद्युत,
Yes,
आपका कौन सा पार्ट था, आप
yes,
करोगे
Pawan.
फिर.
Isostasy, yeah, I will continue then. And Pawan, वो आंसर क्या होगा फर्स्ट वाला जो क्वेश्चन, जो
फर्स्ट वाला
मतलब. हाँ हाँ.
Why
वो
will
मेरे
we
को.
use the Berger anomaly instead of the Fourier anomaly?
So it would be answer like basically in Booger correction we are accounting the material, right? Material attraction of the material between the datum plane and your station point. But in Fourier correction we are not accounting the density of the material, and because of
No,
that I
no,
think.
Vidut, he asked about the anomaly, not correction.
I think in case of the main difference lies or we need freer anomaly in isostatic compensation at that concept, or deep lying object, like when we are trying to study the uh, subduction zone or train's position. At those cases freer anomaly is important, because in some cases over compensated, under compensated, all those cases only Booger anomaly is not sufficient. So for those cases I think freer anomaly is important to explain.
यस अमृत, यस.
Ashudeep, I have one question. So you you mentioned about that we are interested to measure the anomaly. So we, by all the corrections, draw our measured value to the datum. Uh, in some cases, you also asked this question about the geoid and ellipsoid. There is difference between these two. So in some cases, there may be some geoid anomaly at, at some point, maybe due to mass difference, bulging. At those cases, how should we differentiate between these two? That whether this is due to the difference in geoid and the mathematical ellipsoid model, there will be intrinsic anomaly because of this difference, reference model and geoid model. How should we tackle those cases? Did you understand my question?
Yes, I have understand. So question is basically how will I differentiate between the anomaly due to the geoid or due to the modeling method? Huh?
Mhm.
Okay. See, in the most of the cases in the geometric shapes, whether it is the sphere or a cylinder, the 1D line element, the anomaly curve is symmetric. I think mm, in that case we will not get the symmetric curve. I'm not sure.
Okay, actually, what I know that this is the intrinsic ambiguity. Maybe there is some difference, or due to this difference in height at a particular location, there will be some difference in the delta G value, or the anomaly value. We can't actually do anything about that. So this is one of the intrinsic problem or intrinsic error that is we are considering. So I don't think it can be minimized in any ways. So that's okay. That's what I know.
Okay, means it is inherent in that every measurement.
Obviously, because we don't have
Hmm.
any model or anything to minimize or to account those difference.
Okay, thank you.
Okay. Thank you. Your explanation was also good. And now I think Bidut, you can take over.
Okay, some
Oh,
suggestions for me, please.
yeah, Asudev, it's fine. मतलब तुम तो अच्छे ही बोलते हो क्योंकि
हाँ, तुम डिफेंड भी अच्छा करते हो, ये भी एक क्वालिटी है.
वही तो बात है.
Okay, thank you.
Okay, then I will start in the isostatic part. Hello.
हाँ,
नहीं
कंटिन्यू करो.
आप वन मोर थिंग, आपने तो आई थिंक क्वेश्चन पूछे नहीं है कुछ, तो मैं खुद से बताना चाहूंगा. सो इसमें पूछ सकते हैं कि व्हाट इज द डिफरेंस बिटवीन द इज इट द सिलेंडर और ड्यू टू द स्फीयर. सो वो हमें पता ही है सबको कि ज्यादा शार्पली डिक्रीज होता है किस केस में, कर्व जो है. I'm not actually recalling, but I think in the case of the cylinder, the curve decays more rapidly as compared to this sphere, because all it is due to the because सिलेंडर की जो लेंथ है वो इन्फिनिट लेंथ है. सो जो मास है वो कंट्रीब्यूट हो रहा होगा, पास वाला मास भी जितना जाएगा वो एक पर्टिकुलर पॉइंट पे, पर स्फीयर तो एक पॉइंट की तरह ही है. सो वो तो एक टाइम के बाद खत्म हो जाएगा डिस्टेंस पे भी. बट सिलेंडर केस में ज्यादा कंट्रीब्यूट करेगा तो ज्यादा वो एनोमली जो डिक्रीज होना से स्टार्ट हो जाती है.
So Asudev, I have another question that what is the मतलब difference क्या है Booger anomaly and free air anomaly basics?
Basics is that कि it do not account the free air anomaly, does not account the Boygar plate correction, that is due to the mass. The free air means it will have the all the distance part, external effects, that is tidal correction or everything, but do not account has mm, the burger plate correction, which is due to the mass, or that may be due to the mass axis or the mass deficit. But burger gravity anomaly includes all the corrections, whether it is due to the elevation, mass, rotation, everything.
Okay, okay. Okay, then
Okay,
I
then
can start.
I
Yeah.
will also add. I like to add one more questions. We have at a particular location the gravity values, or when we are measuring any values, we have the field values. So during interpretation, while we are trying to model anything, what we should primarily think about, that which model we should try, what should be there in the mind of an interpreter, Ashudip.
Initially, I think we should go for the symmetric case, the 3D object sphere. Then it's all depends on the curve, anomaly curve.
Okay, actually, we probably try with the simple model, and actually there is nothing inside the subsurface that will give us the simple structure. So when we are considering any sphere or anything ideal, we tried simple model and try to get those values considering the ideal structure, and how it is different between considering the difference. I think we change the parameters, and uh, anything add you want to add, then you can.
Actually, that's all that I know. If anyone, please. The question is from which model we should start our observations or considering in the initial phase.
Yes.
Vimal, Pavan,
Sorry, Ansudev, I have no idea.
Gauri,
Sorry, Steve, I don't.
Apita, Agya.
No, Ashudip.
Oh,
Okay. Okay, Vidut, you can start.
Okay, okay.
Thank you, everyone.
Yeah. So just I share the screen at first. Yeah, is it visible? Hello.
हाँ विद्युत visible है.
Okay, okay. Okay. Then at first I will tell something basics about the isostasy, and then about the model and what is the applicability of the isostasy. So basically, isostasy is a Greek word. If we break this isostasy word into the two part, one is iso and second one is stasy. So iso means equal and stasy means station, that is at a particular position or a particular stationary place. So isostasy deals about the adjustment between the upper layer and lower layer of the earth. So how the adjustment is happening between these two layers, how the material from the upper layer goes into the lower layer, and then further back goes to the upper layer of the earth crust. So isostasy tells all about the state between these two layers. So theory of the isostasy is the fundamental concept that tells you that gives you the balance between two opposing force. One is buoyancy force and second one is gravity force. So we can say that isostatic equilibrium is a state of gravitational equilibrium that maintain between the earth crust and mantle, such that lithosphere floating on the denser partially molten viscous underlying asthenosphere, and second one, that earth crust float at an elevation that depends upon mainly two parameter. One is thickness and another one is density. So isostacy control the regional elevation of the continent as well as ocean floor in accordance with the density of the rock that are beneath the earth's surface. So this concept helps us to get to know how something is above, how something is below. So in general, it can tells you how the different topography can be arises on your earth surfaces. Okay, so that the isostacy term, this term first coined by American scientist in 1889. This scientist named C. Dutton, but it doesn't mean that before that this concept is not there. Before that, this adjustment between the upper layer and the lower layer be there, but the term isostasy word was discovered in 1889. Okay, so basically related to isostasy, there is many model scientists given many model related to isostasy, but out of many model, there is three model is important. First one is Aries model, second one Pratt model, and third one Veining Mains regional model. And there is another five model. So I can tell you this five model at the last. These are not important. Basically, this five model based on the only Aries and Pratt model, but there is some modification. So Aries and that both hypotheses are the common. They have the same approach. They have the different approach, but the same destiny. So the extra mass of the mountain above the mean sea level that can be compensated by the less dense region below the sea level, or that can be compensated by the root mass deficit, but the way they have achieved this compensation is different. Basically, Aries they give this model in 1854. Okay, so according to Aries model, uh, is that excess mass above the datum plane is completely compensated by the mass deficit in the root. That implies that it have variable root thickness, and this variable root thickness is proportional to the elevation of your topography. And you remember in Aries model we talked about all the block or something uniform density but varying depth. Aries model main idea that crust and mantle have the same density, but it have a different depth. Okay, so in that figure you see that there is different block in the crust. So crust density 2.67, all the block have the same density, but they have different thickness. So thicker block have the higher elevation. If in that crust there is different block, so if you have block that have thick, that means that have higher elevation as well as much thicker root. So also this Aries model also called mountain root theory. And always remember, this root have the lower density than the surrounding mantle. So main concept about the Aries model, we talked about only uniform density and the varying depth. So if you trying to calculate what is the root thickness by the Aries model. So this is the figure. Let's say you have excess mass, and that mass deficit, excess mass have height R and mass deficit have height H. So if you equate extra mass equals to mass deficit in the root, so you get these types of equation where A is the area, right? H is the thickness of your root and R is the thickness of your excess mass, and your root density lower than the surrounding mantle. Okay, this all about the Aries theory, but Pratt model is just opposite to the Aries model. But he had also wanted to compensation of the excess mass of mountain. But concept is that he told that there is depth is same. Depth is concept, depth is constant, but they block have density variation. Density variation means that here you see that here you see that all the block have the same depth but different density. So in that crust part, density varies, that row 1 greater than row 2 greater than row 3 greater than row 4 greater than row 5, but have the same depth. So the excess mass is compensated by the lateral change in the rock density, or we can say that low density of the crust, low density of the crust at the location of the crustal block. But there is important thing that all the block float at the same depth but different density. And also we can say that higher elevation here indicates that this block have less dense, this block have less dense. And in the previous case Aris model, we talked about that have variable root thickness. Here no, here have no root thickness, here have only density variation. Okay. And third model not, if you want to calculate by the Pratt model the root thickness, so it is that if you have excess mass, that is the height is h, and you have density variation. Okay, so rho c2 and rho c1, it have no root thickness, so x is the crustal thickness. So if you equate the excess mass equals to a mass deficit, you get these types of equations. So from that you get to know the root thickness, sorry, not root thickness, about the density of the crustal block. And from the Pratt model, if you calculate this equation, you get to know that oceanic density, crustal density is greater than the continental crust density. And third model is the Veining Mains regional model. So this model basically tells about the bending of your earth surface. So in that model, it has assumed that crust is an homogeneous elastic plate model, and that can be float on the viscous mantle. Here excess mass is compensated by the rigidity of the lithosphere, but lithosphere has its inherent rigidity, and its rigidity is spread over a broader region that have the topography load. Whatever topographic load above the lithosphere, it can spread over the broader region. So you can get here isostatic compensation, a regional isostatic compensation, not local isostatic compensation. In Aris and Pratt model, you get local isostatic compensation, but in that model, in Veining Mains regional model, you get regional isostatic compensation. So local isostatic compensation is that your uh, root is just located uh, beneath the mountain, but regional isostatic compensation that your root, that have root, it is not exactly below the mountain, it has spread over the region. Okay. So 1 minute. So if we the concept, you get 2 3 main concept from the Aries theory. You get to know thick crust under the mountain, and Pratt theory you get to know about the mid oceanic ridge. Whenever you have mid oceanic ridge, they have a divergent plate boundary, right? So if there is divergent plate boundary, so whenever magma comes out from the lower region to the upper region, so there will be some change of the density. So in Pratt theory, mid-oceanic ridge is very significant. But in Aries theory, as Aries theory is called mountain root theory, so regional continental mount is significant in the Aries theory. And also from the Pratt theory, you get to know the oceanic crust is denser than the continental crust. Okay. And so there is another concept, that isostatic compensation. Yeah. So there is isostatic compensation classification in the 3 types: fully isostatic compensation, second is partially isostatic compensation, that is under isostatic compensation, and third one over compensation. Okay, fully isostatic compensation means that elevation of the topography is exactly same the mass deficit below the sea level. That means excess mass on the top is equal to mass deficit in the root. Okay, and second one, so this is the complete isostatic compensation. Okay, so whatever topography you have seen here above the normal crust, so exactly same mass deficit below the crust. So that isostatic here, I will tell you later what is the isostatic gravity anomaly. It is something another. Just at first I will tell what is isostatic compensation. So fully isostatic compensation, when you have when you have mass above the mean sea level, that is exactly compensated by the deep root zones, and that is excess mass on the top is equal to mass deficit in the root. Second one is partially compensation, or you can say under compensation. That means excess mass on the top greater than the mass deficit in the root. Okay, that means your visible topography has root that are the small. That means your excess mass is greater than the mass deficit. And third one is overcompensation. Overcompensation means that your excess mass on the top that is less than the mass deficit in the root. So if you have any eroded mountain that can be created by erosion, so it have no longer high enough to deep root. Okay, so that is the isostatic compensation for overcompensation. So from that you get to know what is the isostatic gravity anomaly. So isostatic gravity anomaly is basically difference between the Booger anomaly minus computed anomaly because of this root zone created because of topography. Okay, so let's say if you have when you get negative isostatic anomaly, when you have unexpected mass deficiency, that means that you have too much root. But when you have a positive isostatic anomaly, that is it has insufficient root. So in the first figure, in the yeah in the in the first figure you get complete isostatic compensation, and that means whatever you see topography above the sea level, that is the same mass deficit in the root. Okay, so as I told that isostatic gravity anomaly, difference between this Booger gravity anomaly minus computed gravity anomaly because of your root zone. Okay, so in a both here, both of the anomaly is the same. So whatever you see in the topography, according to that, there is a computed anomaly. Okay, and also it is the same deficit. Basically there is no below or upper. In the second case you can see that in the overcompensation, what happened in the overcompensation, you have mass on the top that is less than the mass deficit in the root. Okay, so whatever topography you have seen here, it is not actual because it can be generated because of erosion. Let's say let you think that whatever topography you have before 5 years, that I have written actual. Let's say it is actual, but after erosion your topography is now this amount. So you see a computed root means whatever topography you see in present, in according to that you can calculate it the computed root. But real root is that whatever it had previously, in according to that it can be calculated real root. Okay, so in that case uh, in that case in that case isostatic gravity anomaly also negative, because computed root also negative and real root also negative, right? But real root is more negative than the computed root. You get it this point? Hello?
Yes, ma'am, continue.
Yeah. So in this case you get negative gravity anomaly. Negative gravity anomaly, that is shown delta g and delta g I. Okay, and delta g b is the Booger gravity anomaly, that is because of real root. what is that can be generated because what is actually be there, but in topography that's shown that is actually present, but it is not actually topography that's shown here, it is actually present now, but it is not actually present because it can be generated because of erosion, but it is actually that I have shown. So in that case, isostatic gravity anomaly is negative. But under compensation, what happened? Under compensation, excess mass on the top is greater than the mass deficit in the root. Okay, so whatever topography is shown here, it is also not actual. Actual is shown, I have drawn there. Okay, because uplifting or sedimentation, this topography is generated now. So according the rate at which because of sedimentation or you can say uplift that this topography is generated, according the similar rate your root cannot be generated. So your real root is lower than the computed root. Okay, here both root are negative, but as the isostatic gravity anomaly difference between the Booger gravity anomaly minus computed anomaly because of your root, but here computed root more negative than the Booger gravity anomaly. So here you get the isostatic gravity anomaly is positive. So you get to know these three concepts.
Bidut, I have one question. In
Yes.
which we have three compensation like overcompensation, undercompensation. We use Boger anomaly is negative. Why we are
Yes,
using Boger negative?
because Booger gravity anomaly negative because if somewhere is root means there should be Booger gravity is anomaly negative. बिकॉज जहाँ पे रूट हम लोग मतलब कॉम्पेंसेशन की बात करेंगे, अगर वहाँ पे रूट होगा तो अब कॉम्पेंसेशन की बात करेंगे, अगर रूट होगा तो डेफिनेटली वहाँ पे बुगर मतलब बुगर एनोमली नेगेटिव ही होगा.
एंड ओशनिक एरियाज में बोगर एनोमली पॉजिटिव होती है आई थिंक.
ओशियनिक
हाँ, पवन सही बोल रहा है। उसका रीजन है कि वो जो हायर मास हायर डेंसिटी मेंटल है उसका कॉम्परेटिवली अपर मतलब कॉम्परेटिवली लोअर डेप्थ में मिलता है ओशियन रीजन में, क्योंकि ओशियन लिथोस्फीयर बहुत थिन होता है। एक रीजन है प्रोबेबली के, क्योंकि बुगर एनोमली क्या है जी कंप्यूटेड और जो रियल वैल्यू है उसका डिफरेंस, तो उधर का जो कंप्यूटेड वैल्यू है उसका शायद ज़्यादा हो जाता है वो लोअर डेप्थ में हायर डेंसिटी मिलने की वजह से।
यस हाँ, डेंसिटी इज हायर इन ओशनिक रीजन.
हाँ विद्युत, आई हैव वन क्वेश्चन. Why do we need isostatic equilibrium actually? Is this applicable only for a mountain region or anything like that?
अच्छा अच्छा, डेंसिटी हायर है इसलिए पॉजिटिव.
Uh-huh.
Become settled down. Let's say you have no disturbing force in that particular time. We can, because let's say you have two states. Hello, Amrit?
You go on. You keep continue.
ओके ओके. तो मतलब आइसोस्टेटिक इक्विलिब्रियम मतलब यही है, अगर
Hello, you are
लेट्स से
audible.
या आई एम. हेलो. हेलो.
Yes, please continue.
या सो आइसोस्टेटिक इक्विलिब्रियम मतलब यही है, अगर you have two state, let's say crust and mantle, and in between these two state you have no disturbing force. So at that time we reach the isostatic equilibrium.
Hello?
Hello.
Vidut, you are not audible.
हाँ.
Hello.
Now
Hello.
you are audible. You can continue.
Yes, अमृत, तुम्हारा क्वेश्चन क्या था?
आइसोस्टैटिक एनोमली का सिग्निफिकेंस क्या है, मतलब एक क्यों चाहिए? बाकी बहुत एनोमली हम लोग देख लिए, एक बुगर एनोमली, फ्रियर एनोमली. और ये बस वही रीजन के लिए एप्लीकेबल है ना जिसपे माउंटेन रीजन है, क्योंकि ऑल केसेस पे टोपोग्राफी अंडुलेशन था.
हाँ, मतलब माउंटेन की भी ये मतलब इम्पोर्टेंस है, एज वेल एज मिड ओशियनिक रिज के, जो मिड ओशियनिक रिज जो है वहाँ पे भी ये आइसोस्टेसी इम्पोर्टेंट है, क्योंकि मिड ओशियनिक रिज पे जो डेंसिटी चेंज होते हैं, क्योंकि मैग्मा जिस टाइम गोज टू लोअर लेयर टू अप लेयर, so because of that there will be how the density changes between these two layers. So from that concept comes from isostasy, from the Pratt model.
अच्छा. कुछ केसेस में जब दोनों थ्योरेटिकल मॉडल सेम है एक्चुअली, बुगर एनोमली और रूट जो एग्जैक्ट कॉम्पेंसेटेड मॉडल है, उसके बाद अगर कोई इरोशन है, कोई माउंटेन इरोडेड हो रहा है, तो फिर
तो फिर
तो तो वो जो मतलब उसको क्या बोलते हैं, ओवर कॉम्पेंसेटेड केस है ना, जिसमें रूट का डेप्थ ज्यादा रहता है, तो उस केस में एक मतलब अपवर्ड एक मोशन रहता है ना, जो दिखता है कि अपवर्ड मोशन ऑफ द माउंटेन occurs until next equilibrium. सेम केस एक्चुअली. फिजिकल सिग्निफिकेंस और क्या हो सकता है, यही मैं सोच रहा था, इसलिए पूछा. तो एक प्रोबेबल रीजन है कि मूवमेंट ऑफ लैंड masses upward and downward in this two scenario. और क्या हो सकता है?
इसका मतलब एप्लीकेबिलिटी।
हाँ, मतलब ये जो आइसोस्टैटिक एनोमली मॉडल है, इसका मतलब इसको जरूरत क्या है, ये
हाँ
कहाँ पे
मतलब,
applicable है?
हाँ वही जो जब मूवमेंट ऑफ मतलब आप अपर स्टेट एंड लोअर स्टेट ऑल्सो, मतलब क्या बोले, एरिज मॉडल से जो माउंटेन का मूवमेंट है, मतलब माउंटेन के नीचे जो थिक क्रस्ट है, वो वाला कॉन्सेप्ट हम लोग एरी मॉडल से निकलते हैं, अपैरेट मॉडल से जो मिड ओशियानिक रिज रिज में जो डेंसिटी चेंज वगैरह होते हैं वह निकलता है। उसके बाद जो ओशियानिक ओशियानिक मतलब क्या बोले, ओशियानिक डेंसिटी इज हायर देन द कॉन्टिनेंटल क्रस्ट, राइट? सो ये भी कॉन्सेप्ट प्रैट मॉडल का जो इक्वेशन है ना वहां से आते हैं।
अच्छा. ओके.
मतलब मेरे को ये थ्री एप्लीकेबिलिटी पता है।
हाँ, और मैं भी जो मुझे लगता था वो बोल दिया. एनीबॉडी एल्स वांट टू ऐड एनीथिंग? अशुदीप.
Sorry, I don't have nothing add to it.
ओके.
मेरे को लगता है ये आइसोस्टेसिस से बहुत ज्यादा क्वेश्चन नहीं होगा, क्योंकि ये जो मॉडल वगैरह है ये तो जस्ट एक बेस है,
Okay,
राइट?
Vidut, what is the basic principle that we are using here in the isostasy?
That is the Archimedes principle.
And what is the buoyancy force?
Buoyancy force, because the force, because of that, uh, that acting, that can helps the body to float on something, that force acting on the upward.
Okay.
So I start instrumental part.
I think
कल
कल
हाँ ठीक
करते
है।
हैं
हाँ
कल
काफी हो
करेंगे
गया।
तो।
क्योंकि टाइम भी काफी हो गया है।
हाँ हाँ
हाँ
क्या
एक्चुअली
2
ये
आवर।
असुदीप, ये बुयांसी फोर्स क्या कैसे बोलेंगे, मतलब क्या और डेफिनेशन क्या
Actually,
है?
buoyancy force is the force applied by the fluid or on the particular on the object which is floating or inside the fluid, which try to which apply a force up in the upward direction. So it is the force applied by the this on a object by the displaced fluid. जो suppose वाटर में हमने कोई भी ऑब्जेक्ट रखा है, तो जो हमारा रिमेनिंग वाटर है वो जो डिस्प्लेस, क्योंकि कुछ ना कुछ अमाउंट में वाटर तो डिस्प्लेस हो गया वहां से, तो उस ऑब्जेक्ट पे वो एक फोर्स लगाएगा दैट विल बी इन द अपर डायरेक्शन। और वो कहाँ लगाएगा? एट द सेंटर, एट द सेंटर ऑफ द डिस्प्लेस वॉल्यूम। जो वॉल्यूम डिस्प्लेस हुआ है उसका जो सेंटर होगा उस पे।
ओके।
हाँ, उसका फॉर्मूला आप देख सकते हैं जो होता है, आई थिंक रो रो ऐसे कुछ रो वी कुछ जी,
G
रो वी जी
into
होता
rho
है ना।
fluid into
हाँ,
G.
रो वी जी होता है ना। हाँ, वो फॉर्मूला है।
ओके ओके थैंक यू।
एंड वन मोर क्वेश्चन, व्हाट इज टोपोग्राफी?
टोपोग्राफी
व्हाट डू यू अंडरस्टैंड बाय टोपोग्राफी?
that whatever the elevation above the datum plane, that should be mountain or no.
Okay, so
I have
topography is the description of the surface features of an area. So, for example, how how is the mountains they run area, hills, valleys, or rivers. So, it's all about the surface features of an area. So, I think we should focus on the very basics definitions that can be asked during. Definitely, we will use these words, and we should know the meaning of words, बिकॉज डिटेल में पता ना हो वो चल सकता है, बट बेसिक्स अच्छे होने चाहिए।
yes
आई
okay
थिंक, है ना?
thank you. Yes thank you
ओके,
Asudip,
सो गाइस वी विल मीट टुमारो। यस
yes
विद्युत।
या असुदीप क्या क्या चेंज करना पड़ेगा, आई थिंक मेरा बहुत स्पीड हो रहा है राइट।